Okay, as a review, I mocked up the measurement process for an actual wind turbine blade. This is, of course, just a CAD off the internet, but at least it gives you an idea of the scale and how the complexity of some of the things that we're working with. So if I were to add an instrument relative to this large wind turbine blade, you see it's actually quite small. And the ability to measure particular features takes a little bit of preparation. So if we zoom in here, you can see there's a whole bunch of holes on the end of the blade which helps attach it. And you don't necessarily know the size. You can use this fun little extraction tool, cylinders from CAD. And what it does is allow you to select cylinders of a given size range and extract all of them for you. So that's kind of a fun thing. That was added in this version as well. We didn't have this ability to extract cylinders like that, although we could do circles. But say that the CAD model was off the internet like mine is, and you didn't know the exact size or layout of the holes. What you can do now is go to this multi-geometry construction tool that allows you to lay out circles around the z-axis. And I forgot I need to actually make that z-axis oriented in the correct orientation. And then this will make more sense. If I do my secret little decoder ring, I know that this should be about 1.15 and the size should be around that. And you also have a couple of controls. Basically, you're laying out a pattern around a center and at a given angle. So you can start at a angle that's not just 0. You could actually set that. And you can also set an angular spacing. So if I set all those things up and say, okay, you build a whole bunch of circles in your little preview, and you can just say okay to build those. So that is one really easy way to build a lot of circles very quickly. And now that theoretically should be ready to inspect. Okay, so the next step would be to go back to this instrument over here, make this my working frame, and measure a cross section of this part. And to do that, I can again go to this Measure Geometries tool. I can choose Cartesian, and the way this works is you have a start position, a stop position. In this case, I'm 60 meters, and I'm going to do it every 3 meters just to make it even. And let's see, so stop, 60, spacing 3, and I have to remember to check the little box. And when you do that, you will lay out a whole series of evenly spaced planes that make it quite convenient to define where the cross-section measurement should be. But rather than just building the intersection of the plane in the CAD, you can refine that now to include what's visible from a particular instrument station. And that's done by going to the instrument perimeters definition and building that plane CAD intersection. So I can select my instrument, I can select my surface, and when I do that, I can then select which of these planes to consider for me to build a perimeter and hit go. And what this is going to do is process each and analyze how much of the perimeter is visible from that instrument station and refine the perimeter to be visible so that you're not measuring material that you don't need to measure and that it is ready to measure. So these little cross sections, as you can see, only show the visible portion of the blade that's visible from that particular station. And then all you have to do is connect to the instrument and hit measure. Okay, let's take a look at the instrument side of things. So once I'm connected to my instrument here, what I want to do to use these measurements or these perimeters is go to the line scan cloud profile. This profile allows you to scan it, record it as a point cloud within SA, and open its properties. And what you have here is the ability to select perimeters. You can just select them manually, which makes life really simple, and press enter, and that will assign those perimeters to this measurement profile. The other thing that we've added is the ability to send the data as a cross-section cloud. And if you check that option, what's going to happen is it will actually save it and send it in a much more usable format, which I'll show you now. Okay, the final piece is once the measurement has completed, what we have is a cross-section cloud. And what's unique about a cross-section cloud is that you have each of the sections divided into separate little pieces, which can be turned on and off as needed. So that's really the benefit of this process. What we've done is add a number of additional options as well for building cross-section clouds. So under cross-section clouds, we can build an empty one, which allows you to combine separate measurements into one. You can also go here and say partition the cloud, so you can break the cross-section cloud into the individual pieces and reselect as needed. So we have all of the pieces now for a full cross-section measurement process.